Okay, so here we're going to be talking about limits, which are basically what a function approaches as x approaches a certain value, as opposed to what it equals. And I'll get to why that's important in a second. So here we have f of x, and that's 2x squared minus 2x divided by x minus 1. We can just factor that 2x out of the numerator. That's 2x times x minus 1 divided by x minus 1. Now, what if I asked you what f of 1 is? Right? Well, if you plug in 1, you get 2 times 1, which is 2. And then times 1 minus 1, which is 0. And then the denominator is going to be 1 minus 1, so it's 0. So f of 1 doesn't exist, because you can't divide 0 by 0. It's not 1, it's not 0. And that kind of makes sense why you can't divide by 0, because let's say 0 divided by 0 did equal something, say x. That would mean that 0 times x is equal to 0, right? If you multiply both sides by 0. But anything times 0 is 0. So x could be absolutely anything. So it's just undefined because it could be anything at all. Okay. But, you learned in algebra, this just simplifies down to, if you cancel that out, it just simplifies down to 2x. So let's try graphing this. It's going to be a slope of 2, y-intercept 0. It's going to look like this. Like that, yeah? But we have to be careful, because when x is 1, the function doesn't actually exist. So, let's go back. Instead of plotting a point where x is 1, we should plot a hole. And that just is there to represent that this line isn't actually defined at that point. Oh, that was bad. But do we really care that it's technically undefined? Because we really would like to simplify this to 2x. And how do we get back f of 1? How do we get the function evaluated when x is 1? Well, we can do something called a limit. So here's the notation of it. LIM, limit. And then at the bottom here, you do what your variable, your input, is approaching. It's approaching 1 here, right? So x approaches 1. And then whatever our function is, so f of x. All right. So what this means is, what does f of x approach? What does f of x look like it's going to be when x is 1? So if x is going to 1, we see f of x is approaching that hole. But what is the y value of that hole? It is 2. So that means that this limit is 2. Right? Okay. And then you can have functions with holes, right? But you can also have piecewise functions that you might want to do this with. So let's say g of x is equal to this piecewise function. Let's say it's equal to x squared when x is not negative 2. And when it is negative 2, I'm just making this up. Yeah, let's make it 0. So let's graph this. So it's going to be, well, g of negative 2, when x is negative 2, it's going to be 0. So let's plot that point. It's right about there. Okay. But then for the rest of the values, it's going to be x squared. So a parabola, it's going to be 1 squared is 1, 2 squared is 4, it's about here. Actually, it's going to be, yeah, whatever. Let's see if I can draw this well. Nope, not so well. Okay. And then same thing on the left side, except as x goes to negative 2. Here, so g of negative 2. Like, if you plug in negative 2, you'll get 0. But when we're graphing, we want to know what's the limit as x approaches negative 2 of g of x. What does g of x go to? What would it be if it wasn't defined? Or if it wasn't 0? Well, we can just plug it into this other function. So, because we're near negative 2, so we're like negative 2.001, and that's not negative 2. So we can just plug it into this section because it's not negative 2. So negative 2 squared is 4. So that means we're going to have a hole at negative 2, comma 4. So let's say this is about 4. It's an awful parabola, but you get the point. So that's basically what a limit is. And later I will talk about one-sided limits and eventually what they're used for.